Hello and welcome back to the channel. So this is the first part of a series of us recreating Battle City game in Godot 4.4. This one's gonna be split into parts just to make the recording a little bit easier, and in the end I will compile all the parts in one long video, just like the most of the previous videos that I've made. So let's get this thing started. Let's create a new project and find a proper place for it. And let's change the name here to Battle City Tutorial. I will have the create folder as on. I will also name this Battle City Tutorial. The renderer is gonna be forward and version control metadata is Git. So let's hop in and let's start creating. So in this first part we'll handle few things. Let's start by checking the version that I'm using. This is 4.4 stable, as you can probably tell, and I really suggest that you should also use the very same version. Okay, so as per usual, I will start by creating a new scene. Let's find empty scene, and that's going to be our main scene and also our first level. So let's create new folder and call this scenes, and I will save it there. First thing that I would like to do is change the clear color of our project. So going to project setting and searching for clear, I'll find rendering environment setting and changes to full black and save it. And then I will start by actually creating our first level tile map. But before, let's add a standard camera. So camera 2D, that's gonna make sure that we're rendering from the middle, which sometimes makes sense. And let's start by adding first tilemap layer. So this is where we will create our first environment. So what we need, of course, is the assets file. So I'm going to create new folder and let's name this assets. And then what I can do is bring the assets file. So give me a second here. And here it is, Battle City 2 PNG. It's not fully completed yet, it's gonna get updated as we go, but this should be really enough for us. And as you can see, this is the file I created. This is my my level of pixel art. Not too bad, I might say. So we have some example tanks, the environment tiles, the power-ups, the eagle, and the broken flag representing the lost game. So to make all of it work, we need to set up some preparations here. So let's go to tilemap layer. Let's go to tileset and create new tileset. We need to set the tile size to 8 by 8. And this is due to the fact that our environment tiles are 8 by 8. So let's go to a tile set. Let's bring this down here. And now we can start configuring it. The problem is, as you can tell, that not everything is perfectly matched, but we don't really care. Only this part is what we're really going to use as a part of a tile set. Okay, so then what we need to do is just start painting. And if you don't know how to paint your levels or how they should look like, what you can always do is use some kind of reference, right? If you just search the internet for it, you probably can find something like this to have as a reference for your level, right? And I will be mostly copying what we're seeing here, right? So with this as a reference, I can start painting. Let me scroll out a little bit. Also, let's set the camera zoom to a proper value. So that should be 3 by 3. So now we have proper working area. And we must remember that we would like the whole level to fit into the camera bounds. So again, looking at the level for the reference, we can start painting. Going to our tile map, I will just choose the tile representing the brick. So I can select it and I can start painting. And as you paint, you can see that the pixel art is a little bit blurry. This can be fixed real easy by going to project settings and searching for filter. And in textures, we would like to have default texture filter set to nearest. And now it's way clearer. Okay, so we have this, I believe, as a protection for our eagle. We must remember that the separation between the parts of the map should be 2 times the tile size, 16, because that's the default size of our tank. So actually I can grab this and start painting. You can follow along with me, or you can create like your own map. It doesn't really matter. I'm just trying to reproduce here what was actually in the game. And we need to move this to the center. So the map is symmetrical, so the same shape should be on the other side. So this 1, 2, 3, and go to here. So I believe this should be our map, at least for now. There's one different tile being used, and this is like this concrete tile, which is indestructible. All other parts we should be able to destroy. So that's going to be our basic map. See how it looks like. We probably would like to create some bounds with concrete indestructible tiles, or adjust the size of our camera. We'll see how to handle this in the next part, but basically that's it for now. The other part I would like to implement right now is to add some kind of singleton that's gonna handle everything that's going to be happening in our game. So what I'm going to do is I'm going to go into global, and I'm going to create a new node, and I'm going to call this GameManager. And let's put this into scenes. Let's create this. This should be a global variable, name GameManager. All of this looks good, so we can already do a little bit of coding. So let's see, we'll need to export how many lives the player has. And we'll also export group tank points, representing the points the player gets for destroying each tank type. And we'll just export group and empty string to finish the export group. Small tanks are worth 100, and then we increment by 100 for each type. And also would like to keep track of how many tanks of each type were destroyed. Also, we would like to track which level are we in. So stage number and current player score. And that's it. That's the basic setup for what we need in this part. In the next part, we'll start working on the tank movement. So I'll see you there. Goodbye. Hello, and welcome back to the channel. This is the second episode of our work to recreate Battle City in Godot 4. As you can see, I'm right now using 4.4 stable. So if you're not at that version, I recommend that you update to the latest stable. And this is where we left off, which isn't really much. We have a camera, we have a tile map layer, and we have some additional script that's gonna work as a game manager. So I believe this is the right point in our development to add a player. So let's go to scene, new scene, choose other node, and we'll search for area 2D. with that, I will rename that to player and add the basic node that we need, which is the sprite 2D, and then we will also need a collision shape. So let's grab that and let's set our sprite first. So go to sprite and then in inspector I would just grab this and drop the battle city. As you can see, this is of course a little bit too much, but we can limit the things that we are displaying for a player by enabling region and editing it. I will choose the snap and I will snap to pixel, and let's grab this for now, and we'll adjust the width because it should be 16 by 16 of course, but maybe can we just make sure that this is in the middle if it's not. So let's do grid snap instead, and let's do 2 by 2. And let me, okay, and with that we can update it to the proper values that it is in the middle, so it should be 13 by 13, and now it's in the middle. The sprite itself doesn't really matter. What matters is the collision shape. So we can go, you can take a look at those values again. This is x1, y2, width and height are set to 13 because the sprite itself is actually smaller than the grid size, which is, in our case, we'll be working with 8 by 8, but actually 2 times of that, like 16 by 16. So for the collision shape, I will of course add a simple rectangle shape, and this time I'm gonna put this to be 16 by 16. And we can go to scenes and save our player. Okay. For now, there's not going to be anything interesting going on, but we can place our player already. So instantiate child scene and choose the player. And let me put it right here, or maybe even in the middle here. Let's check the transform and round it up. Okay. Remember, we're working with the multiples of 8, so -8 by -24 should be good. Okay, moving on, I would like to make it move. So to do that, I'm going to create new script. Let's move it to the scripts folder. Player is fine. Okay, so with that, we can actually start working here. We need a few things here. One is of course the speed, which we can manipulate. So this is 25. We need the reference to sprite. So control drop it to get that reference, and I believe that's it for now. We will need to start the velocity, so let's create a variable for that. And we need to set up our inputs. That's also rather simple. Going to project settings, and we'll just do oops, this is up, not apple. Down, left, and right, and we can already add shoot. So that's going to be W, S, A, oops, A, and D, and space for shooting. So this is our input map for now. Moving on, I would like to make our tank actually move. So we will need to read the input. So let's create a simple function here, and that's one gonna get called get input, and it should return vector2. So we'll just simply process the input. We'll assume that it starts at 0. If input is action pressed right, actually we don't need that variable, we can be smart about it. We can just return early, return vector2, sorry, right. If input is action pressed left. Is action pressed up, return up, and then return vector2 0. And that's all we need from here. Okay, so that's that. And then we need just to apply this. We can do it in physics process. So the input is equal to get input. If there's no input, we'll just return. Then what we need to do is actually is to update the rotation of the tank, right? Because if we're going left, right, the tank is rotated by minus p divided by 2. That would be 0 rotation. Then we have pi divided by 2, and then of course pi, right? And we're working with a radians here. You know, in terms of degrees, that would be again 0, 90, 180, and minus 90. But that's basic math. You should probably know that. Or at least I hope you do know that. So let's update tank rotation based on input vector. Okay, let's write that function. Input vector. get some space here. Input vector is supposed to be of type vector2, and that function should return nothing, so it's void. Yeah, let's do just that. If input vector is equal to vector2, right, the rotation of our node should be set to pi 2. Else, if input vector is equal to vector2 down, the rotation has to be pi. Else, if input vector is equal to vector2 left, oh, we need that one here. I mean, input vector is equal to vector2 up, rotation should be set to 0. And let's see how that works for us. Yeah, I can see that the tank is rotating correctly, so that's cool. Let's actually make it move. So this is going to be rather simple. We can calculate the velocity as input vector times speed times delta, and we can just say that the that the position is equal to velocity. And now we will be moving. The problem is that we're not colliding with the tiles, right? And there are many ways to handle that, but let me explain one thing about movement in Battle City, which is going to heavily influence how we're doing collisions and how we are moving our tank. So if this is our grid, you know, like a crossroad between grid tiles, if we have a tank that is moving, it has a snapping added to its movement. Meaning, in normal circumstances, since we are working in 16 by 16 grid, you could only turn at the crossroad if you're perfectly at the center of it. But that's not the case when it comes to Battle City and movement. The player has its life made easier because there's a snapping enabled, meaning that he doesn't have to be in a perfect position to be able to turn perfectly in a crossroad, right? There's a snapping enabled, and there's a tolerance to the snapping of how much of the tank has to be like off the grid or not in the center to be able to turn. You can play this online, and once you try playing and really looking into the controls, you will like feel it, right? So the game helps you actually turn left and right and change directions when going around corners, right? Because the game is detecting how close to a crossroad you are and whether you can actually perfectly turn into the different direction. So we actually have to implement that, right? So how to do this snapping? Let's start by actually going to project settings, and we need to set the proper layers. So project settings, general, let's search for layers, and here we will have tank, we'll have brick or grid, however you like to call it, and then I will also add a bullet. Okay, given that we have that already, we need to actually see the collision shapes. So if I go to visible collision shapes in debug and turn that on and run the game, I will see that the only thing that has a collision shape is our tank. So it's time to add the collision shapes to our grid. So go to tile map layer, tile set, and what we need to do is go to paint section, and in inspector editor for our tile map layer, go to physics layer and add physics layer. And we would like that layer to be to exist as a brick layer and be able to collide with tank and bullet. Perfect. And now I can go to my paint and select a property editor, and physics now have physics layer 0, which I can click, and I can then just paint the tiles that I know that the player should be able to collide with. So definitely those two. And if I will run my game again, I can see that now all of the tiles also have collision shapes, but this is not yet set to colliding. This is due to the fact that we're actually using area 2D instead of the character body. So we would like to manage our collisions manually, and this is mainly due to the fact that, as I said, we want that snapping enabled. Okay, so we need to actually change our tank node a little bit. So let's go into our tank node, and we will add a few things here. To handle the collisions, we'll use raycasts, and to keep everything nice and tidy, I will group those under node 2Ds. And why I would like to keep those grouped in node 2Ds is because I will treat those node 2Ds as a folders for our raycasts, and I have to use node 2D because those raycasts, they have to actually follow our player. So the plan here is to have our tank and have a set of raycasts, 3 in the front and then 2 to the sides. These ones will help us detect the front collision with any kind of obstacle, and then these ones will work for snapping. Okay, so let's set them with the proper starting values. I'll create node 2D, as I said, and I will say raycasts, and inside I will add another group, call this front raycasts, and then we also need left, and as you can probably guess it, right. Let's add raycast 2D, and as I said, we will need 3. Let's call this one, the first one, center raycast, then left raycast, and then right raycast. And we need to set them properly. So first thing is the collision masks for all 3 of them should be detecting the grid. So let's select 2. Then we need the starting positions for those. So let's set transformation. This one is going to be 1 and 1. Or sorry, 0, 0. And then the target position is what interests me the most. As you can see right now, it's going way down and in the wrong direction. So the target position should be -8. And as you can see, it's in front of us, right to the edge of the collision shape. For the left raycast, we will do position set to, where is it? Position -6 and also -8. And to keep it symmetrical, of course, the right one should have 6 and -8. And to keep it simple, I can always favorite the property to see the transform at the top, which is really cool. So these are our front raycasts, and let's handle those now. So what I will do is I will go to the script, and I can create front raycasts array, and I can create those already. So front raycasts, and the type is array of raycast 2D. And what I can do is just grab every single node path here. So this is how you can group your nodes in code. And now I can check just to show you those when you're running the game. They are populated properly. So here's our array of raycasts. Okay. So now after we update tank rotation, we can calculate is front colliding. So this is very simple. I can just say front raycasts any, and I can just write a function here, raycast return raycast is colliding, right? So I can just create an anonymous function to check if any of the raycasts from that array is colliding with anything. And I can just say if is front colliding, return, do not apply the velocity. And see how it works. Well, we're not moving at all, so not good. And this is probably because I'm using the reference to a function instead of just calling it. right now it is working really good. As you can see, if we are colliding, that means we're not moving. So this is our simple collision. The problem is that with the snapping, if I am standing here, I should be able to be snapped to the correct position right about here. Or if I'm here, I should be able to be snapped here, just to make turning easier. And we'll make that feature optional and turn it on and off with a flag. And if you don't like it, you can just disable it with one click. So let's export var, enable snapping, and set this to true by default. But again, if you don't like it, you can just disable it. And to make it work, we need to add the proper raycast to left and right side of our node. So add child node raycast 2D, and I will call this left. Oops. Sorry for that. Left side and raycast. Duplicate this and call this left side start raycast. Both should be in the second layer. Then we need to set the position for both. So this is 3 and 7, and the target position is 5 and 0. So is this the left side? This is the right side, sorry. So -5 and -3. And now this is the left side. Correct. And this is end because it's at the end of the tank. And then here we need to set this to -3 and -3 and -7. And the target is -5. Sorry, -5 here, of course. So this is left side start raycast. And now we need to repeat this very same process for the right side. So right side end raycast, and right side start raycast. And again, that should be 3 and 7, and the target position should be 5 and 0. And you can play with those values to influence how snapping behaves. And this should be 3 and -7, and the target should be 0 and 5. Perfect. So we have those set up properly, and I believe they should work. And yeah, and they do, as you can see, register the collision. So this is all good. So going back to our code, we can also group the right side and left side. So already right side right raycasts. This is array of raycast D, and I can just grab the paths, and then I can do left raycasts, it's plural, raycast D. And we can just drop left. Okay. So we have like pretty much everything. So we have our position set, and then what we will also need is to start the previous direction, and you will see why. The previous direction is gonna be, we'll start our vector to 0. And I will say that previous direction, and I shouldn't use camel case. There is no reason for it. Previous direction is input vector. And here we will handle snapping, but only if enable snapping is set to true. So we need to calculate is left side colliding, and I can do that by saying left raycast any, and can recreate the very same function. So since we are recreating these functions again and again, we can just create a new function to reuse it. And I can say is raycast colliding, and I will say raycast to D, return raycast is colliding. This is very, very simple function that basically does nothing other than calling that, but I can omit the repetition by just saying how did we call this? Is raycast colliding? Yeah, okay. Is raycast colliding, and I can reuse it right here. So now these two are using the very same function, and it is way shorter. And again, we'll use it one more time. Is right side colliding is equal to right raycast any is raycast colliding. Remember, we do not call the function, we just pass the reference here. Okay, and if it does, we'll just apply snapping. So we'll need to pass an input vector is front colliding, and then we'll also need to pass is left side colliding or is right side colliding, so whether we have collision on left or right side at all. Okay, and with that we can write our apply snapping function. So apply snapping, it gets input vector, which is vector 2, is front colliding, which is boolean, it's side colliding, which is also boolean. And first thing we need to do is get 3 and wait 1 frame to avoid the off collision by 1. And if input vector y is not equal to 0 and it's not true that front colliding and is side colliding, we will adjust the position to be position snapped to vector 2 of Let's see, our tile size is actually, oh, let's see, it's 8 based on our tile set. Yes, it's 8. Okay, so we can go here and just create a quick variable, which is going to be 8, and I can just say that this is going to be, since we're moving in y direction, we need to snap to x. Else, if input vector x is not equal to 0, and it's not true that front colliding and is side colliding, position is equal to position snapped 0 and 8, meaning we should use the tile size, of course. And that should be perfect. And I believe that's it. Let's see how this behaves, and if at all. We're calling this, okay. So I'm moving, and right about here, as you can see, I'm pressing the key once, and I moved into the center. Right, I am here, and I am snapping correctly. So if you compare this with the situation where the snapping is disabled, if I am here, right, I'm not being snapped to the center and I cannot move any further, right? So that requires us to be very precise in our movement. It's really up to you to decide which type of movement you would like to see, but to be honest, let's turn this on again. Often in retro games, in grid based movement, you will see this sort of snapping being turned on just to make sure that it is easier for a player to move around. Here I don't have anything, so it does not trigger, but here, as you can see, it should. Again, we might have some edge cases here, but I'm not gonna bother with them because it's already too long. Like, for example, here you can see that this collision is not being registered properly, even though it should. Right, just like here. Not sure why. Let me check. But yeah, basically this should be it. Let me check if the values are correct. I believe for the right side, yes, we should be right to the edge. So this should be correct. Yeah, I believe that's actually it when it comes to our snapping and our movements. So I will see you in the next section where we'll handle the shooting and destroying the grid. See you there. Hello and welcome back to the channel. Today we continue our work on Battle Tank, Battle City tutorial. We have our tank, we have the movement system with the snapping. Now it's time to handle shooting. So let's start by creating scene, new scene, other node. Let's search for area 2D, and let's rename this to bullet, or I don't know, tank shell, but bullet seems reasonable enough. Let's save this, and we will need to add sprite 2D, and we will need to add collision shape 2D. So first, let's drop a correct sprite here. So going to quick load, I can quick load that, and of course that's gonna load the whole sprite, but instead I'm gonna enable region and edit it and drag those handles to make sure that we're only displaying what is needed for our tank. And the step is too big here, so let's change this to 1 by 1, and now we can align these perfectly. Of course, the same goes to collision shape. We can create new rectangular collision shape, drag it around, and to make sure that it aligns perfectly, you can see that the size has to be adjusted. 3 and 4 for Y should be good enough. Okay, so we have our bullet. We need to actually make it work and move. So let's create new script. Going to scripts, creating bullet GD script, and we can start coding. Let's provide a class in here. We will maybe provide a speed value, and I'm gonna use 50 here for the start. We will need to stash and remember the direction of the bullet, and by default we'll give it up. And then in process you can just do position is plus equals directions times speed times delta, and this is enough for now for our bullet. We also need to make sure that we assign to the correct collision layer. So the bullet is a bullet and it collides with brick, and it doesn't collide with the player tank itself. Maybe we will change this later when we will work on the enemies shooting us. But now let's go to a player. Let's collapse all of those rekas and let's add a shooting system. So I will use a marker 2D. I will do this because it's going to allow us to really easily place it in the right place. So just at the edge of the barrel. So this is, I believe, minus 5.5, and this is the place from which our bullets should spawn. Perfect. So now we need to add a script to it to actually spawn the bullets. So let's rename this first to shooting system. And then I can attach a script, save it in the scripts folder as a shooting system.gd, and we can start writing our code. So let's add a class name, shooting system, and we will have a variable here for whether we can shoot or not, and this entirely depends on the fact where we already shoot and there's a visible bullet on the screen, so only one bullet is allowed. Okay, let's see whether we have the input action for that. We have, and this is a space. Okay, so what we need really here is a reference to bullet scene that will instantiate. So preload, and we find bullet scene here. Perfect. So now in the input function, I can say if input is action just pressed, shoot will spawn projectile, and we'll set can shoot to false. Let's create that function. And let's instantiate a bullet. Let's set its global position to our position. And we will set the direction to parent previous direction. And then we need to rotate it correctly, right? So again, if bullet direction, actually we should probably move this to ready in a bullet, because this does not really consider the shooting system itself. Yes, so the rotation can be set in a bullet in ready function. And if direction is equal vector to right bullet, rotation should be set to p divided by 2. Vector down is rotation equal to pi then we have minus pi divided by 2. And finally, we can say that the rotation, otherwise we can just set the rotation to 0. Okay, so this is handling the rotation of the bullet. And then going back to our shooting system, we can say get tree root add child bullet. But to re-enable the shooting, we need to know when the bullet gets destroyed, right? So what we can say is that our bullet will have custom signal called bullet destroyed, and we will connect here to anonymous function stating that can shoot is true. Really easy, and this provides us with this gives us the fact that there's no need to create another function. It's just there already as an anonymous function. So going back to our bullet, I believe that should be it when it comes to spawning it. Let's see whether we can run this properly. And okay, there's no signal defined, of course, so there's an error. So let's define that signal. Let's see, maybe put it here. Signal bullet destroyed. Okay, we don't need to do anything with it yet. Yeah, okay, we spawn this. which is great. But as you can see, it's not being rotated properly, and in the start it is not moving. So let's reload that. Okay, there was some kind of hiccup, but it's not getting rotated properly, right? So let's see. There's a direction, and let's see. Bullet direction is get parent previous direction. Okay, let's see whether we can fix this. Fix it by simply, oh, it's gonna trigger every single time. My bad. So just do else here, and now it gets rotated. Perfect. I just wonder about that situation where it doesn't move at all. Let's see. Player collision. No, it shouldn't collide. Oh, I know what it is. This is due to the fact that only set this previous direction not equal to vector 2 0. Let's try this now. Yeah, perfect. That works. So now what we need to do is actually handle the collision between the brick and the bullet. And if we take a look at our bullet, and you can see that this is 3 pixels wide, right? So we need to actually think and consider how it will hit our tile map, because our tile map is 2 tiles wide, meaning this is 8 pixels and this is 8 pixels, right? And then we have a bullet that is 3 pixels wide, meaning we need to consider different scenarios. We can have a scenario where the bullet hits 2 8 pixel wides, right? This is 3 pixels. We can have it hit something in the middle, and then we can have it hit the tile just on the edge partially. So we need to handle all of those scenarios when it comes to calculation of the hit and collision between the bullet and the tile. Okay, so let's start very simply. So we need to have, let's see. We need to actually set up and listen for a proper signal. So this is going to be on body entered. And we need to check whether that body is a tile map layer. Let's see. If body is tile map layer, print hit. Let's try this. Yeah, it gets registered properly. But of course, sorry, right now we're able to spam those bullets, but we'll handle this. So let's actually write a function here. Can call this handle tile map layer collision and pass body here. Handle tile map layer collision, which is going to be a tile map layer of type tile map layer. Okay. First thing we need to do is we need to find the, oops, let me color this. We need to find this 2 points, because the moment of contact for the tile and the bullet is going to look something like this, right? And this is going to be like the center global position of our bullet when they do collide. And then these are the points of contact. So we need to find those points, and we need to check what did we hit, and did we hit anything at all. So I'm gonna calculate left collision edge, which is going to be global position plus left edge position rotated towards rotation. So what is the left edge position? Well, it's very easy to find if we take a look at our bullet. If this is the global position, then the left edge position, or left corner I should say, position is minus 1.5 pixels to the left, and then minus 2 pixels up, because as you can see, right, this is pointing downwards. So to find that point starting from, it's like vector math, right? We need to go here and here to find that point, and again go here and here to find that corner. So this can be easily just written into constants. So left corner position is vector 2 minus 1.5 and minus 2, and right corner position is vector 2 1.5 and minus 2. So that's rather easy. We need to change this to be left corner position, and of course we need to take the rotation into consideration, because the case we just analyzed was just for the bullet pointing up, but of course our bullet can hit the brick from every side. So we need to rotate that points according to our rotation. And then I can find right collision edge. Say that this is global position plus right corner position rotated towards rotation. Okay, and with that, we definitely need to do a few other things. We need to, if we hit the tile up, we need to QE3, and we need to emit bullet destroyed signal. Other than that, we need to, of course, check the calculation between the bullet and the tile map. So let's write a function check bullet collision for corner, and we'll pass here left collision, let's call this corner, right collision corner, left collision corner, and we need to pass tile map layer there. So let's write that function. Let's copy the name here, and that's going to be corner, which is going to be vector2, and tile map layer of type tile map layer. What we need to find first is the tile position according to the place we discovered the hits. So we need to check, let me show you. We need to check if there's a tile at this position, because remember, we can have a scenario where only one corner actually hit the tile and second did not. So we need to check whether here is the intersection between the bullet and the tile. So tile position is equal to tile map layer local to map tile map layer to local edge. So first we need to convert, corner. First we need to convert the corner to a position in the tile map, and then we need to convert that that position to a map, and then we know what is the tile position in the tile map, and with that we can get tile data and check whether there's a corner there. Basically, if there's a tile data, there's a tile there. So I can say tile map layer get cell tile data and pass the tile position there. Again, this is not the position in our standard coordinates, but rather in the coordinates of a tile map, meaning, for example, this one, right? It would be, I don't know, it would be 1 and 0 probably, right? This one would be, this one would be 1 and 1. Oh, let me check this. Yes, I believe so, right? Because they're also indexed from 0. If this is 0, 0, that would be -1 and 1, right? Again, this is in the coordinates of the tile map, right? So this is 1, 2, 3, 4, -1, -2, -3, -4. So going back to our bullet, we need to check if there's a tile data there. So if tile data is equal to null, we do nothing, right? Meaning there's no tile there. But otherwise, we will do tile map layer, and we can remove a cell from a tile map by saying on the tile position, set the -1 and vector 2i -1 -1, and that is going to clear the tile, or at least it should. So then we need to repeat this for the right corner, and we have this. And if I shoot, as you can see, I'm able to remove 2 tiles at once, but also only 1 tile if I do not hit this perfectly in the middle. But there's still one problem that we have to solve, because these ones, they're supposed to be like a, I don't know, concrete or reinforced blocks, and you should not be able to destroy them. So we need to customize our solution a little bit. And the simplest way we can do it is to go to our tile map inspector and find custom data layers. This is of course on our tile map layer. And I can add a custom data layer, say that the type of it should be just Boolean. I'm gonna call this can be destroyed. Okay. And then I'm going to go to our tile set zoom in on that and choose paint, and I'm gonna paint custom data, and then I'm gonna tick this one on, and this I'm gonna leave as off. And with that, I need to add a check to my bullet. So let's see here. I will additionally say or tile data get custom data can be destroyed. This is negated, right? So like, is it equal to false? And then it's also gonna ignore the collision, at least for the brick part. So as you can see, I am no longer able to destroy the concrete, but I am still able to destroy the bricks and even 2 bricks at once. So yeah, this is it. This is the basic setup for how you can have bricks that can be destroyed in our Battle City clone. So I will see you in the next one. Goodbye. Hello, and welcome back to the channel. In this episode of recreating Battle City game in Godot 4, we will work on enemy spawning and enemy movement. But let me address a few things here. As you can see, my Godot now looks a little bit different. This is due to the fact that I am using custom theme from Passive Star Minimal Theme. If you'd like to get the very same look, take a look at the previous video about making Godot a little bit more modern. Another thing I will be using is scripts IDE by Maran23. I also mentioned it in the previous video. I recommend using this, so just go to Asset Sleep, find scripts IDE, and install this, and then go to project setting plugins and enable, and that will make your coding experience a little bit better. Again, if you'd like to know more, refer to the previous video. So, working on the enemies. Before we do that, I would like to get one thing sorted. I will create a helper node for our player GD, and this part, update tank rotation. This part of code will also be used in the enemy node. So what I am going to do is go to scene, new scene. I will create empty node. I will call this tank rotator, and for this tank rotator I'll attach script. Going to script, call this tank rotator, so this is fine, and I will give it a class name. And save it. And then I'll just go to player, copy this function, or actually I will cut it out, pass it here, and I will change the naming for that to be current direction. And of course, since this is an empty node, right? Well, we don't have a rotation in that script, so we'll just do get parent rotation. I will assume that this is going to be a node 2D or something that extends node 2D that actually has rotation. And we could actually guard save this a little bit. right? And make it a little bit smarter, because I could just do ready. I could cache that parent to not obtain it every single time I will call update tank rotation. Parent node, oops, sorry, parent node 2D, parent node is equal to get parent, right? And then I can just say parent node and refer to cached node here. Also, I can just simply check if parent node is not node 2D, I can just return, right? And I hope that's going to work. So let's go to player, and I can just open player, and here I can instantiate child scene, tank rotator, and here I have an error, right? But I can just get a reference to a tank rotator, and here I will say tank rotator update tank rotation. Oh, we need then to call, of course, the instance instead of a class. And now everything should be back to normal. And it seems it does. So with that, we can start working on our enemy. So first thing that we need to create is a set of nodes that will work as that will have functionality of spawning the enemy itself. So I will create new node 2D. I will call this enemy spawner. And then I would like to add spawn points to that. So let's get node 2D, and here I can add spawn points, which are markers 2D. Typically in a game, what we have is 3 points where enemies are spawning. So let's try to set this up. This is going to be spawn left, spawn center, and spawn right. And let's set them in a proper place. I will enable grid snap just to make sure we're placing them in the right localization. So that should be -96 and -104. I believe this is not centered. Like now it's aligned properly. Okay. So this should be moved to center. And this we should move to the right. So I guess around here. One problem that we have though is the fact that our whole area is not limited. So the simplest thing to do that, what we can do is grab this tile that we know is indestructible and just paint it. So it should go from here to, we can grab a line from here to, I believe here. Everything here. And this should go like here, one below, here, and here. And now our area is limited and we can place our spawn points properly. So now, as you can see, they're in the right place. This is spawn left, spawn center, and spawn right. So we have that covered. Of course, our player should start. Well, it doesn't matter for now where he starts. Okay. So we have this set up. What we will also need for our enemy spawner is timer. And I will call this spawn timer, and I will also make sure to call this one spawn points. And with that, I can create enemy spawner script. Open and create. Perfect, and I can start coding. So we'll have to define some constants first. And I did a little bit of a research, and I believe that they are right values according to original game design. Total enemies per level, this is 20. Const max enemies on screen, and that's 4. Actually, this is rather interesting because that value comes directly from the fact that the hardware couldn't handle more enemies. We'll get spawn delay, and I will set this to 2. And we will need enemy scene to load. So let's quickly just create that. And we'll use area2d as a root node. I'll call this enemy, and I will make sure to save this in scenes folder. Perfect. So with that created, I can go back. Yeah, we're in enemy spawner. I can get the reference to that. And I will call this enemy scene, of course. Perfect. So we have that set up already. And we need to have some variables to track the things that we need. So enemies remaining. And this is going to be total enemies per level at the start. Current enemies, it's 0. And enemy spawn index is equal to 0 for start. We need to get the reference to our spawn points. And these are just array of marker 2D. And let's go back to main and let's drag and drop them. So this is left, center, and right. And we will need reference to our spawn timer. Okay, we can start coding our functions. So we need function ready, and we must make sure that spawn timer wait time is equal to spawn delay. And I will say that spawn timer timeout connect to spawn enemy. And of course, we need to start spawning these. If enemies remaining are less or equal 0, and if current enemies is equal to 0, this is like indication that the level was completed, because we don't have any more enemies to spawn and there are currently no enemies present in the level. So I can just for now print level complete. And then I can return. If current amount of enemies is greater or equal max enemies on screen, we return because we don't want to spawn more enemies. Then we choose random spawn point, one of the three, the left, center, right. So random spawn point is equal to spawn points random integer divided by this modulo spawn points size. So that's the way to get something random. Or maybe there's just pick random. Okay, we can use pick random. Perfect. Then we need to instantiate the enemy. And set the enemy starting position to be random spawn point position. Then we need to get tree, root, add child, and we will do not code but rather call deferred, making sure that this is called when the thread has available resources. Right, as you can see, deferred calls are processed at idle time. Idle time happens mainly at the end of process and physics frames. So whenever we have like free resources, spawn enemy. And these are like really micro delays that do not have any impact on our gameplay. We will also need to know when the enemy is destroyed. So re-exited, we'll create a function called on enemy destroyed. Okay. And yeah, we just need to create that function. It can be empty for now. And we will do, say, for now, just pass. And then we can say current enemies plus equals 1, enemies remaining minus equals 1, enemy, do we need enemy spawn index? We'll need it in the future, plus equals 1, and spawn timer start. Okay, we will also make sure that our spawn timer is set to auto start, and do we need it to be one shot? Yeah, we can make it one shot because we restarted by hand here. Okay, so we can also add the back statement here that will say spawn enemy on screen, and this is current enemies remaining enemies remaining. Perfect. So what should happen when enemy gets destroyed? Well, the current enemies, we should decrement that, and if enemies remaining is greater than 0 and current enemies is less than max enemies on screen, spawn enemy, oops, else if enemies remaining is greater than 0, spawn timer start. Right, so this should actually help us to make sure of the amount of the enemies currently on screen. So what's left to do is actually create the enemy. So let's go to our enemy and let's start adding the things that we need. We will need tank rotator. We will need collision shape, and we will need animated sprite 2D, and we will need array cast 2D. Okay, let's open. Oh, we don't have enemy script, so let's create one. Let's go to scripts and let's add a class name, enemy, and let's set the tab first in 2D. So when it comes to animated sprite, we can create new animation with new sprite frames, and let's go to sprite sheet and let's fix those. I believe these are, let's see, how many are there? 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7, and 7. Okay, let's see. Because those should be animated, but I believe we need some kind of offset here. Maybe they're good. Yeah, they're good. Okay, so let's grab this and let's play it. That looks fine to me. So this is going to be default animation that will autoplay. So this is good. That allows us to create collision shape for it. So the collision shape should be rectangular and it should be definitely 16 by 16. Okay. I can see that this edge is a little bit offset, like it's not even. So going to this and this, I can see that we should offset this probably by 1 frame, and remove these two. Oh, okay. Can I just remove, delete frame? Okay, now it's even, right? So the sprite is offset. That's my fault. I am the one who created them. Creating art for a game is not my strength, but we have that working nevertheless. When it comes to arraycast, it will point forward. So 0, 0 is good. 0 and -8 is the target position. So we're targeting front. And we are colliding with brick and layer 4. And layer 4 actually should be enemy because I want the enemies to be able to bounce off each other. We'll just create enemy here. Okay, and we will need 2 more things for our animated sprite 2D, and we can do this by adding more assets. So let me bring those. Let's put it in asset, and this is just FX, which are like some effects that we will use for spawning and for explosion. Okay, so going back to animated sprite 2D, I will create new animation. I will call this explosion. And let's go to FX and see whether we can find something nice here. So first thing, we have to figure out the size. So vertically, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I believe. Oh no, this is vertical. 11 or 10. Let me see. I don't remember the settings for that. The size is definitely not correct. I believe this is 64 by 64. And I am correct. Perfect. So let's see. This could be our explosion. Let's play this. Of course, this is pretty slow when running at 15 FPS. So let's run this at 20. Nice, good enough. And then we need a spawn animation. So let's create new one. Spawn. And let's see, this is also going to be 64 by 64. And we can do something like this. And also run it at 20 FPS. Yeah. Or maybe 15. Yeah, 15 is better. Perfect. So we have default and it's not going to be autoplay. The spawn is going to want to autoplay, but we will also make sure not to loop it because we just want it to play once. Okay, so let's see, is there anything else we need? I don't think so. We will need a reference to a tilemap. And to make it easy for us to obtain, we will put this in a group. So going to groups, we can make it global. Let's click on plus and let's add tilemap layer and we can make it a global group. Perfect. And now we have everything. We have our animations, we have our tilemap added to a group. We can go to our enemy and we can start coding. So let's start by grabbing references to everything we need. So this is reference to a collision shape, reference to animated sprite 2D, reference to raycast, and the reference to a tank rotator. Let's create a flag to track whether given tank is spawned, and let's create some movement variables here. So this would be a good time to actually discuss how are our AI tanks moving. And actually, this is rather simple. When the tank is moving, he does that for a period of time, like for example for 1 second. After each, we test whether it should change direction randomly. So even if it collides with the next direction that we choose, this is fine. When playing the original game, you will often see the tanks moving rather chaotically, but since there are only 4 movement directions, this is like fine because it will find a direction in which it can move, even if previously it will be stuck on a wall for like 1 tick. So for that we need move timer, and we'll need move duration, and we'll need the tilemap layer to check where we are colliding with tilemap. And we need just directions array. It's pretty simple. This is of course vector2 up, vector2 right, vector2 down, vector2 left. Okay, so now let's get some space here and let's start coding. On the ready function, we need a reference to TileMapLayer, which we can obtain by using getFree, get first node in group TileMapLayer. Perfect. And we'll call set random direction function here to set the first direction. And we can start coding set random direction function. So set random direction. We can say that movement direction is just random direction, so pick random. And we need to check for whether in given direction we will encounter a tile. So while check for tile in direction of movement direction, we will say that if there's a tile in given direction, we need to redo the direction setting. So this means check if in given randomly picked direction there is a tile, right? And if there is, pick a different direction, right? If here you encounter the tile going down, let's just go left or up. Okay, so we need to write that function now to solve that issue. Check for tile in direction, movement direction, this is vector2, and we can say it returns boolean. So position to check. What position should we actually check? This is a global position of a tank plus movement direction, and we need to move it to almost edge of the tank, because if this is a global position of a tank and we know here we have 8 pixels because the whole tank has like 16 pixels, we need to check almost this position but moved forward just a tiny bit. And testing this, I found out that 0.1 is enough for a proper check. And then I can say tile position is TileMapLayer local to map TileMapLayer to local position to check. So we need to convert the position to check into the coordinates of TileMapLayer and then into the coordinates of a map to obtain the tile that is in that position. And you can do that by using get cell tile data. Get cell tile data under tile position. If there is a tile data there, return true. So we would have encountered a tile on that position. Else, return false. And then once we finally decide on the position, we can say tank rotator update tank rotation movement direction. Okay, so this is everything we need to set the initial rotation of a tank. Yeah, well, we've been coding for a while here, so let's see whether our tanks actually spawns and rotates correctly. So let's run the project. And we have a tank, and we have another tank, and we have another tank, and as you can see, they're changing directions. They have different random directions. Of course, we don't see anything else other than just the spawn animation, but this is fine. And we'll have a problem here. Invalid access to property or key root on a base object of type null instance. And there might be a problem where like the spawning is not correct because we're not inside of a tree. This is very easy to handle. We just need to check whether we are inside of a tree. If we're not, we just return, and that will make this pesky error go away, and we don't need to worry about it anymore. Going back to our enemy, this is what happens at the start. Right, we're spawning, setting random direction. Then it's just a matter of actually making it work. So one thing that we need to handle at the start is if we spawn our tank, you see that the animation is like too big. The tiles we're using are 16 by 16, but the animation itself is 64 by 64. So for the start, what you can do is go to inspector and set the initial scale on the transform to be 0.25, and that's gonna adjust the animation to be smaller. As you can see now, it fits 16 by 16. Okay, then we need to know when the spawning animation actually finished, because after the spawn animation, we would like our tank to appear and actually start, causing havoc on our map. So we need to listen on a signal from animated sprite 2D called animation finished. Let's connect this signal and let's check for animation that just finished. If it's spawn, we will set is spawn to true. We will set the animated sprite to the scale to vector 2 of 1 and 1. And I'm going to say play default. Let's see where that works. Spawn and have a tank. The problem is that it's kind of wobbly. So let's see what's going on there. We have this. Let's see. Default. And it's moving left and right. Let's stop this and go to assets, velocity. This should be 16 by 16. And there shouldn't be any problems there really. Okay, now it's correct. Maybe I will have to fix other sprites. But let's not worry about this just now. Now this should be looking good. Yeah, now it's fine. Perfect. So with that, we have everything we need for animation. Let's actually make it work, make it move. So I can go to function process, and first, if it's not spawned, just return. Then we say that move timer is decremented by the delta, and even if timer is less or equals 0, we again change the direction to a random direction, and we reset move timer to move duration, and we say position plus equals move in direction times speed times delta, times delta, and that should be partially good enough. So let's see. Yes, this is working, but we're not colliding with anything, so we need to plug into our raycast. So we can use our raycast to detect collisions and again setting random direction. So if raycast 2D is colliding, right, actually, yeah, we can do it like this. If it is colliding, we need to set random direction again. Let's see how this works. As you can see, it works almost good. One thing I'm a little bit worried about is, as you can see, sometimes it looks like the sprite is overlapping the brick when you're moving sideways, so it's not perfectly centered. We can fix that by simple snapping. So if movement direction or actually maybe we can do it smart. So let's adjust the position by saying position is snapped to vector 2, and this should be 8, or actually movement direction times 8. Yeah, let's see how that works. And I believe now we're staying on the grid. Or not, ideally. Okay, let's write this another way. So if movement direction x is not equal to 0, we'll snap it to vector 2, 0 and 8. And then else or else if movement direction y is not equal to 0, position is equal to position snapped vector 2, 8 and 0. I believe that should help. Yes, that looks correct to me. One thing that is missing is that the tanks are not bouncing off each other, and this is of course because we did not assign the collision to it. So the layer we're using here is 4, and they should collide with each other and everything else. Let's try this now. I hope they will start colliding. And no. Oh, this is because we did not set our Rycast to collide with RES. Let's try this again. Yeah, we can see that they're already colliding with each other. Okay, perfect. We have that set up. One thing that is missing is the fact that we cannot destroy our tanks, enemy tanks yet. So let's add a simple function here called this explode that will set the speed to 0. We'll disable the collision. Can say set deferred disable to true. We need to also change the animated sprite scale to 0.25 because the collision effects is 64 by 64. And we need to play the explosion. Perfect. And then we will say if animated sprite to D animation is equal to how did we call it? Explosion. We will just free. And the one last thing is for us to adjust our bullet. So it should collide with enemy. And let's see, on body entered. But this is area. So we need to listen for the area collision. Let's find area entered, connect, and then we just need to make a check. If area is enemy, area as enemy explode and we free the bullet. So let's see where we can destroy the enemy tank. And it seems that we can, which is great. And I will leave you with that. In the next episode, we'll handle the enemy shooting and destroying our base. So thank you for that. We have working, moving enemies. I will see you in the next one. Goodbye. Hello. In this section, we'll work on enemy shooting. We will also work on some adjustments to our sprites and how player is rendered. But mainly we will focus on enemy shooting system. Before that, let's start by adjusting the zoom in our camera main. As you can see by those purple lines, currently zoom is too big because even if we run this, well, not the whole playable area is visible. So I will adjust this to be 2.5. And I believe this to be the correct value for our case. Next thing I would like to handle is actually the way we handle our sprites. So I prepared new sprite atlas. Let me bring that in, and if you would like to add this this is going to be on a GitHub. So this is, I believe, Battle City 5 file. Let's bring that in and bring it to assets. And as you can see here, the difference is that, can I zoom that? No. The difference is that everything is grayed out so that we can modulate it. It has some UI elements, some other minor adjustments. So if you'd like to use it, I would have to go to player, and I will have to use animated sprite instead because we have animation there. So let's do add child node, animated sprite to the animation, new sprite frames, and let's open animation panel here. And let's see. Oops, I will have to open the sprite frames, and we have default. We can set it to loop and autoplay on load. Go to assets, Battle City 5. These are all 16 by 16. So, oh no, the size is 16 by 16, of course. Let's grab these two and let's set this as default autoplay, and let's hide the sprite. We can actually remove it altogether. And now if we run this, we have our animation. The problem, of course, is that we don't want this animation to play when the player is stationary, like not moving. So we will have, of course, to adjust this. Let's go to our script. And what we will need is we'll have to get the reference to our animated sprite. Okay. And with that, we have to check in our physics process what to actually do. So if we are not moving, which is indicated by vector2 set by input vector set to 0, we need to do animated sprite to d set frame and progress frame 0 progress 0, which will prevent the animation from playing. And as you can see, it is playing correctly now only when we're moving. So we have that out of the way. I would like also to be able to set the color of our player. So let's export var color, and we'll use color gold by default, but it is exported, so we can change it whenever we want. And we can just say animated sprite to the modulate is equal to color sorry, and then our tank is colored, which is great. So we have that out of the way. Let's see, what else do we need? This is all good. So the next thing that we can handle actually is our enemy shooting. And then let me see, we could probably just get rid of the sprite 2D. Let's see. Yes, we can just get rid of that. We don't need it anymore. And we could remove it from the node 3, as we are using animated sprite 2D right now. Let me turn mouse highlight. Okay, so going to our enemy, what we'll need is actually make our enemy shoot, which they don't do right now. So to do that, I will go to enemy and I will add child node. marker 2D, and below that, as a child, I will add a timer. So I will call this enemy shooting system, and then call this shoot timer. And since this is like definitely separate subsystem, I will create a script for that. Let's place this in scripts folder, open and create, and let's add a class name here. So enemy shooting system. We'll export few variables here. So the speed of the bullet, which will depend on the type of the tank. Minimal shoot interval. And max shoot interval. In seconds, of course. We will grab the reference to shoot timer, and this of course is a var, and we need a reference to a bullet scene. So let's go to scenes, find a bullet, drag and drop this, and call this of course bullet scene. We'll also need to track whether the tank can shoot right now, and basically with all of that, we need to set up the signal from our shoot timer. So let's grab this, let's connect to timeout and connect it here. Perfect. Then we need to set up our timer. So let's see, in inspector, this is all good. We can start with the default values for our timer. We'll do necessary adjustments via code. So in ready function, shoot timer wait time should be defined as a random from range from minimal shoot interval and max shoot interval. Not x but max. Okay, and we just start it. Then the magic happens in our timeout. Okay, so if we cannot shoot, we just return. And then since we're spawning a bullet here, we will set can shoot to false. Next step, let me get some space here, is to actually instantiate the bullet. So bullet is equal to bullet scene instantiate. We'll set the global position of the bullet, which is going to be the global position of shooting system node, which actually has to be placed correctly. So let's see. We definitely don't want those to spawn from the center. Let's disable that, and let's place this. I believe the correct value is minus 1.8 from where we will spawn the bullets. We may need to adjust this based on tank type, but let's leave it for now here. So this is where we spawn the bullet from. Then direction of the bullet is equal to get parent movement direction, and we need to set the rotation for the bullet. I wonder, maybe we did this already in this shooting system. We do bullet direction and we set the rotation here, so no need to do this, it's already there. Okay, we can get rid of that code. Then bullet speed should be bullet speed, and then we need to make one change, because if we take a look at our bullet and the collision mask, right, we're colliding with a brick, which is okay, but then the enemy bullet will collide with the bullet itself and not with the player, so we need to adjust the collision masks, and we can do it simply via code. So bullet set collision mask value 4 to false, do not collide with the enemies, and bullet set collision mask value 1 to true, which means that it's gonna collide with the player. Get tree root add child bullet, and then bullet on tree exited connect, and we can create anonymous function here saying can shoot is equal to true, and that should allow us to have our enemies shooting at us. Let's see. Oh yeah, but the problem is they do stay in place, right? So let's see what's the problem. The problem is the bullet speed, which was not instantiated to any value. Let's start with 100 and let's see how that goes. And we can see that our enemies are shooting, which is great. Okay. Then we need to decide what to do when the bullet hits the player. So if area is an enemy explode, and QE free. So this is good. We can do very same check for a player, right? So if area is player, we can say area as player explode and QE free. Could not find type player. This is probably because we did not define the class. Class name player. Perfect. So we have that sorted out, but we need that explode function here. So let's write this. So the idea is to play the explosion animation. So going here, we will need to go to explosion effects. So effects with new animation, call this explode. Go to explosion effects, and I don't know, let's do, oops, this is too big. The size is 64 by 64. Let's grab this one. And let's increase the speed. Let's see how this looks. Kinda cool. The problem is we will need to adjust the size of it. But that's totally doable. So let's say animated sprite 2D scale is equal to vector 2 0.25 0.25 and animated sprite 2D, play, explode, and then we need to also, for our player, disable all the controls. So speed set to 0, set physics process to false, and set process input to false. That's it, but we need to actually destroy our player node after that animation finishes playing. So let's connect to animation finished. Let's check if the animation is actually explode animation. And then we query free. Okay. We also need to check for when the player collides with an enemy tank, right? So let's see. What do we collide with? We don't need to collide. Well, we need to collide with other tanks. And brick and enemy. We don't need to collide with our own. Okay, I believe this will be the correct mask. So then we just need to hook to a signal of area entered. Area entered, let's connect to that. Let's check if the area is enemy. If it is, we just call explode again. Okay, so we need to check two things. And we're too slow. Speed, let's do it 75. The collision with the enemy. Yeah, and it works, as you can see. Oh, but it loops, right? So let's disable looping. Perfect. And I would very much like to check where we can collide with a bullet once one of the enemies shoots our way, but I believe it is just working. It just works. Okay, come on, shoot me. And it works. Perfect. So with that, there's one more thing to add in this section, and it is actually to add the victory lose condition. And this is very simple. We will create eagle scene. Let's go to scene, new scene, and create new scene, area D, and I will call this eagle. Let's save this in the scenes folder. And what do we need here? We need sprite 2D, and we'll of course need collision shape. So with that, let's set the sprite. Quick load the Battle City 5, and of course we need to set the region. Let's edit this to match our eagle. Let's make sure to set this correctly. Snapping to pixel and to grid is set. Step is set to 1 by 1. I could also do pixel snapping. It would be the same, but it's easier to see the actual grid. So we have that. We need to add the collision shape to it. I mean shape to collision shape. This is also very easy because we know that's 16 by 16. We need just to bump it up a little bit. And we need to actually add this to our level. So let's instantiate eagle and place this in a proper place. And we do have snapping. So it's 97. Oops. Okay. Perfect. Then we need a little bit of code for our eagle. So let's see. First thing I would like to do is to add a mask for it. So in project settings, 2D physics, I will add eagle and make sure that this is actually the layer for it, and it should collide with enemy, and it should collide with a bullet. Perfect. So now we can add the code. Let's put it into the scripts folder and create. We will add the class name and set it to eagle. It will have a signal of game over, and we need a reference to sprite to turn this into a flag once it gets hit. So we need to create a function that will change this to flag, and this is just sprite to d. We can change the region rect. We set let's see, we set here, where is it? Yeah, we can change this by code, and I happen to know that this is 49 by 80 by 16 by 16. So these two first are the XY coordinates, and then there's width and height. And we need to do some stuff for whenever hits our eagle. So let's connect to area entered. I can say if area is bullet, or area is enemy, we need to change the flag. We need to call Q3, but only for a bullet. So let's do game over emit first, emit that signal, and then if area is bullet, we'll do area Q3. Okay, and here we need to also disable the collision shape to not have this trigger again. Disabled. Okay, let's actually test this and let's see where we can lose the game. Let's go here and let's try it by our own, and speed is null for some reason. Okay. Oh, we need to provide bullet speed for our shooting system. Strange. Okay. Bullet speed, let's set this to 100 for the player. Let's try this again. And we have lost. Okay, and this has to be deferred because we're flashing queries. So let's do set deferred, property name, or we can just do property is disabled, and this is set to true. And let's see, and we have lost. We can check for that. Well, we don't have GameManager yet, but we can simply say print debug lost. Perfect. So this is how we can lose the game. So thank you for that. These are some updates to our enemies and to our gameplay. In the next section, we will probably create a game manager and start working on different types of enemies. I'll see you there. Thank you. Hello again. So in this section, we will work on different enemy types and managing how the enemies are being spawned. So we will do this by one of my favorite features of Godot, which are resources. So let's start by creating a resource script that will define our resources. So let's create new script. Each should inherit from a resource. So let's make sure to choose that. And when it comes to name, I will call this a tank type. And let's save this into scripts. So create and save. Perfect. And we will have a class name for this, tank type. And we'll export some basic properties for our tank here. So export enum, because the types of our tanks are just limited set. Basic, fast, power, and armor. Tank name is of course a string and will start as a basic. Then let's define a few properties here. Float is a speed, health. Most of the tanks in the game have 1 health, but there's one type that is armored and has like 4 health. Int equal to 1. We'll export the minimal shoot interval, and let's set this to 4, and then max shoot interval float and set it to 8. Export bullet speed, which is a float, and will be 200. And how much points is given given tank worth? So 100. And with that, we can create our resources. So looking at our folder structure, we need new, which is going to be resources. And we can just create new resource. Let's call this one basic tank. And we will attach a script here. So this is a tank type script, and let's duplicate this 4 times. So we need fast tank, we need power tank, and we need armored tank. And I'm just duplicating files by pressing Ctrl D, if you wonder how I did it so fast. So let's set the properties that we need for our tank. The speed is going to be 25, health is 1, bullet speed is going to be 75, and the points is going to be 100. And then going to the fast tank, what we need to change is the type to be fast. The speed is going to be 50, shooting interval 3.5 and 7.5, bullet speed 125, and points, let's do, I don't know, also 125. Then we go to power tank. So let's change this to power. The speed is 45, health is 1, 3 seconds and 6 seconds. Bullet speed, let's do 110, and let's do, I don't know, 150. Okay, and then there's armor tank. Or most likely armor, because that should be the name. Okay, the type is armor. The speed should be lower, I believe, so let's set this to 30. Health is 4, 2.5 and 5.5. Bullet speed is 100, and the points is going to be like 150. And of course, adjust those as you see fit and needed. So now we have to get all of this and integrate with our spawning system. Okay, so going to main and enemy spawner, we need to do some adjustments here. First thing we are going to define is we are going to define the tank types dictionary. So already tank types, and we'll have a dictionary that's gonna associate the tank names with the resources. So I will say basic, and this is going to preload basic tank like configuration. Fast, which is going to preload the fast tank configuration. Then we have power, which is going to preload power tank, and we have armor, which will preload armor. Okay, now with all of that, what we can do is for each level define enemy array. So in this array we need 20 entries defining the types that we should spawn by a type name. So we will do fast, power, basic, and basic. Then we do basic, and you can adjust this, of course, as needed. So we know for each index, right? For each index, which enemy to spawn. Then we'll do basic, 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 and fast, basic, basic, fast, and power, and then we do fast, power, power, armor. And this is just example, like the more armored tank and the more power tanks you will spawn in given level, the higher the difficulty supposed to be, of course. So let's see how we need to adjust that. Let's see, what we need is to get the enemy type. So tank type is tank types at enemy array at enemy spawn index, and this allows us to just say enemy tank type, oops, tank type is a tank type. Of course, passing this property means nothing right now, as we need to actually use it. So going to our enemy, we need to define the tank type. So let's do, we can export it just for fun. Tank type is of tank type. And then we need to use it to instantiate everything that we need. So given that the properties are also connected to the shooting and the bullet, we need a reference to our shooting system. And with that, we can just say speed is actually equal to tank type speed. The health, which we should define, health is tank type health. The points are equal to tank type points. Do we have a points? No, we do not. So let's also add that. And then the properties for the shooting system. The bullet speed and the shooting. Perfect. There's one thing though that I believe is missing right now, and it is to add the animations that should be playing whenever whenever we are spawning given type of tank. So let's go here and let's adjust this. So I'll create few new animations. This is going to be basic. Let's see. Armor, fast, and power. And we need to create all of these. So let's go here. This is Battle City 5. Remember that this is 16 by 16. Let's see. This is basic tank. Then the next one is fast tank. Then we have power tank. And the last one is armor. Perfect. So we have that. So we need to actually use these, right? So if we're spawning here, we're not playing the default, but rather we're playing tank type, tank name animation. And I believe this to be all that we need to spawn different types of tanks. Let's see. Yeah, as you can see, we're spawning different types of tank now, which is great. The next thing is to actually take into account the fact that not all tanks have 1 health, because there's an armor tank type which has 4 health. So instead of using explode directly, we need to create hit function and say health. It should be health. Let's see, health H. Health minus equals 1. If health is equal to 0, we explode then. And we need to adjust this in our bullet scene to whenever we hit the enemy, we call hit instead of explode. And let's see, is there any other problem? I don't think so. And this should allow us to have different types of tanks. There's still, oops. Oh, I believe there's also one other thing. In enemy, whenever we call explode, we need to disable the enemy shooting system, right? So enemy shooting system, let's see, we need to clear the timer. So let's see, disable, shoot timer, we could disconnect. What else could we do? We could do process mode disabled, and that should actually disable the timer, right? We could also do, I know, I believe that's gonna be it, right? So that the tank does not shoot when it is playing the explosion animation. Going to enemy, if we explode, we must do enemy shooting system disable. Okay, so now we should have different types of enemies. I would love to find the armored one. So let's see, in our main enemy spawner, the last one is the armored one. So let's change this to see whether the health system actually has a point. I shoot him once. I shoot him. Oh no, I died. Let's see. 1, 2, 3, 4. Perfect. It works. So this is how we can incorporate different types of enemies to our game. Thank you, and I will see you in the next section. Hello. In this section, we will work on the UI part of our game. And what I mean by that is mainly the level part of the UI. As you can tell, right now it's pretty empty, and what we should have on this left side is the amount of lives of our player and the tanks are left to destroy. So let's handle that, and to actually get this going, I will start by creating a new empty node, and I will call this GameManager. I don't really like that name, but we need one node that we can treat as like the a God object to communicate between all other nodes. So let's add a script here, and going to scripts, let's create this GameManager. Let's create a class. And what we'll have here is we'll have this one is going to actually handle the lives of player. GameManager height autoload singleton. Let's see. Do we have that already? Global scenes GameManager. So this gets auto-loaded for some reason. Oh, we already have that. Perfect. So we need to get rid of that and move that to scripts. And in here it loads from scripts. Perfect. So with all of that set up, what we can do is we can start working on our UI. So let's add a canvas layer and let's move it like here and call this UI, and we will save that scene as a branch. So go to scenes, save this, and this way we can open it up as a separate branch. And let's start adding. So we'll create this left side panel in our UI by using color rect first. And let me see, when it comes to a color, we need something grayish. So that's the value I have chosen. This is 4C, 4C, 4C. And when it comes to setting this up, we would like it to be on the left side and actually span across. One thing that we need for it is to set the anchor point, container sizing, and so on and so forth. So let's see. The problem is, of course, the size. I will set to 192. And then the anchor preset. Well, basically, if we run it right now, it's not visible because it's outside of the camera bound. So we need to position it inside of our camera. And now it's here. And this is going to be the place where our UI will live. So let's start by adding margin container. Each span across. You can just override the beam overrides, and the value here is 42 for everything. Perfect. So this is done. The next node we need is VBox container, because we would like to stack stuff horizontally. And what we will need is a grid. So grid container, and I will call this player lives grid. Well, basically, is this player lives grid container? This is more like enemies grid container, to be honest. And let's make sure to access as unique name. And then below we are adding another VBox container. but this should be a child of VBox container. And here we will add a label. And I would like to call this one player because that's how it is the original game. So alignment should be center, center. And going to theme overrides, we have a font for that, or we don't. So in the assets, let's create new folder and call this font. And then I can just drop it. And this is Minecraft font that I am using, but you can use anything you'd like. So now I should be able to click load this. And of course, for our label, we need to change the color to black and then the size. So font size be 42. Perfect. And then below that, we need to create an HBox container. And this is going to hold the information about the lives of the player. So we need a texture rect. And here we must be smart when it comes to the texture. So let me see. There are two ways to do this. Showing file another. Yes, actually, we can use and this is a cool trick. Normally, as you can see here, there's no texture region in texture rect for UI. There is one, and we are using one when it comes to I don't know, for example, the eagle, right? We are using texture with a region, right? But there's none for the UI texture rect. But what we can do is go to texture, new atlas texture, and then as you can see, we can load the atlas and edit region. So what I can do is just load this, right? And then I can edit region to actually match what I need. So this should be 16 by 16, I believe. So now it's one more here. And one more here, even it goes out of bounds. But it doesn't matter. So now, as you can see, I actually can use this part as a region, but I need to use atlas texture. So the size of it, it should be 48 by 48. Let's see, 48 by 48. Perfect. And I should be able to, I believe, find modulate. And I will make it just red like that. Any kind of red will work. Okay. And next to it, I will add a simple label. And I will call this player lives label. And let's see, by default, I can set it to 3. But of course, we need to specify theme overrides. And of course, it could be done with theme, but there's not so much UI now when it comes to this game. Okay, let's see, alignment should be set to center. And I believe we're done when it comes to this part. Center, center. And that's good. Let me just fix the alignment here to center, center. But this does not matter really. Okay. So we have that. And this is everything we need for our UI. So we can just start scripting. So let's go to scripts and open and create. And this is going to be rather simple. We need just few things, right? We need to populate the enemies and then update player lives when something happens. Okay, so let's get references to the stuff that we need, and this is enemies grid container, and we can access as unique name player lives label. And what we need is to set the texture for enemies, and this can be achieved rather easily in assets. I can create new resource, and that's going to be Atlas texture. I'm going to save this as enemy UI texture. I will load the Atlas from Battle City 5, and then I will edit region to match this. So let's drag this, because this is just a resource, so we can save it, which is really good. Let's try to make it 16 by 16. Okay, perfect. We close this, we can save this, and we have enemy texture, and I can get a reference to that. And then what I can do for the ready function, say for I in 20s, and just not make any magic numbers, I can say enemies per level, and I am putting it right here because I know that in the original games it doesn't change. It doesn't matter the level, it's always 20. So what I can do is create texture rect, by calling the constructor new, saying that texture rect texture is enemy UI texture, and I need to set the custom minion size. That's the vector of, I believe we can again go 48 by 48, and player live enemies grid container at tiled texture rect. Let's see whether that works. So we're using this here in UI, and when running this, okay, I have it. The problem is the amount of the columns, because everything right now gets into one column, and I believe that the default design is to have 2 or 3. Let's see. Let's try 3 columns. Okay, yeah. Now we can see the amount of the enemies that we have in our level. Perfect. So now we have that populated, And what I can also do is I can say that we need to set the amount of lives for our player. So I'll create a function called this update player lives with player lives as an int, and say player lives label text is equal to str to convert to string player lives. And at the start, what I can do is say update player lives, get GameManager, and we have player lives there. And then in our GameManager, I will require the reference to UI. And I can say UI should be of class, well, it should be of class UI, right? So let's create a class here. Okay, and that allows me to say here GameManager UI is equal to self, and we can set it here because it is ready. So then in GameManager, I need to create two functions. One function is called decrease player lives, and I can say that, well, UI should be set at this moment, right? So there's no need to check. So I can say player lives minus equals 1, and if player lives is not equal to 0, I can say UI update player lives. Perfect. And that should work. Okay, no errors there. What is most interesting is what should happen when the enemy gets destroyed. And to handle that, we'll go to enemy spawner, and here on, when we destroy an enemy, we will emit the signal enemy destroyed, and we can say enemy destroyed emit, and then knowing that we have that signal in the enemy spawner, can go to node and connect this. I can connect this to I should be able to connect this to GameManager, but there's none currently. So what can we do? We can just trigger that globally then. So I can say GameManager enemy destroyed, and I don't need a signal. Perfect. So what should happen in enemy destroyed? Well, nothing much really. We can just say enemy destroyed and say UI decrease enemy display. And in UI, I can just write that function let's see, decrease enemy display, it returns nothing. And I can say player live, enemy grid container, remove child, and I just need to remove the last child, right? So enemy grid container get child, and I need to pass the index, and I need to know the last index of our child. So that's gonna be last child in grid index. It's going to be player lives, enemy grid container get child count -1. And that should decrease the display. So let's see, I need to, oh, this is like the armor tank, and I think this is working. Yeah, when the tank gets destroyed, we decrease the amount of displayed tanks. So this works very good. Okay, also, if we lose a life, right, this is currently not being handled correctly. But managing the lives, our lives, is something we'll handle in the next section. So I see you there. Goodbye. So in this section, we will handle player lives and also player invincibility. And this is because in the game, as you know, once the player crashes into something, he gets respawned at the starting location, and he is invincible for a short period of time, meaning no shot or no enemy tank can harm him, like he has this protection aura or something. So let's figure out how we actually can create this. So going to our main, I will start by adding a marker to the and placing it where I would like my player to spawn and respawn, and I will call this player respawn point and move it up here in the hierarchy. And then in the player itself, I will grab a reference to it. So one thing I can do is just say well, I could just grab a reference. So let's put it maybe here, doesn't really matter. And on spawn, what we'll do is we'll call respawn function that will create. So respawn. And we'll need a few things here. We'll say that the global position is equal to player respawn point global position, right? Remember that this respawn function is like opposite of explode function. So what we need to do is reverse everything we did here. So what we need is to say that the speed is set to, let's see, we need to set it to 25, right? But this can be changed, so what we actually need to have here is a variable called current speed, and in respawn we'll set the current speed to speed, current speed to 0, and here on the respawn we'll say current speed is equal to speed. Then we need to use current speed for our calculation, so here. That's one thing reversed. The other thing is we need to activate physics process and process input. We need to set the scale. So animated sprite to the scale is set to vector 1 1, and we play the default. Perfect, so that's one thing. And it seems it is working, and right now we are starting here where the marker is. Okay, but there's something more that we need to do, and this is to introduce our invincibility system. So in our player, I'll create invincibility system. So let's add a 2D node, call this invincibility system, and it will have invincibility timer, so a timer, basically how long the invincibility should be active, and then we will add animated sprite to the and call this invincibility animated sprite. And to use it, actually I will update the Battle City file. You can find it in the repository. Let's bring this, and let's see. Yeah, this is the updated version. As you can see, I added those two frames that will be like our invincibility animation on top of the tank. Okay, so with that we can create a new animation, new sprite frames, and default is good. I can just go to assets. Here, this is 16 by 16, and just choose those two frames. And if we change that default and play this, you can see this is how our invincibility will look like. This is definitely too much. Change it maybe to 3 FPS, and we need to loop it, so this is correct. Okay, then it's just a matter of coding our invincibility system. So let's add a script, go to scripts, and open, create, and let's start coding. The class name, same as the node, get references to the timer and to sprite. By the way, the timer setup is rather easy. It should be one shot and 5. And that's all we need. Let's see. Already can start invincibility because we always are invisible on the first player spawn. So to start invincibility, we say that we need to show this, and we can autoplay. Oh no, we don't want that. Okay, and we can get this hidden. We need to start the timer, and we need to play the default. Okay, and then of course we need to hook to the timeout. Oh, not here. Disconnect and remove that. Again, timeout, we need to connect to invincibility system. Perfect. And of course we need to reverse what we've done in the start invincibility. So hide it, and of course also stop it. And then we need to know whether the player is currently invincible. And we can do that by using the getter property. So invincibility timer, if it's not stopped, that means we are invincible. And this can be used in our player. So by default, if we crash with the enemy, we explode. But we can create a calculated property here, or a getter, or whatever. Also, is invincible. Check the... Oh, do we have the reference to invincibility system? No. So let's drop this. So we use that to calculate it again based on the invincibility system. So now we need to not be invincible to actually explode. Oh, come on. It's invincible, and it's not invincible. Then there's always a matter of colliding with the bullet, right? So here, area is player. That check is not enough. We need to also check whether the whether we are invincible. So if area as player is invincible is false, then we explode. Okay, otherwise we need to get rid of the bullet too. So now when we respawn the player, what we need to do is say invincibility system start invincibility, and if we do that, to be honest, we don't need to trigger this already. So let's run our main scene and we start being invincible, and let's try it and crash with the enemy. Oh, too late. Okay, let's extend the timer just for testing to 25 seconds. And let's see whether our invincibility system works. So yeah, I'm getting shot at and nothing happens. And I can go through the enemies. Perfect. So our invincibility works, which is very good. So let's reverse the wait time of a timer to 5 seconds. And then we need to figure out what to really happen when we explode. So let's see. We're going to our player and to our player script. We have explode, and if animated sprite to the animation explode is finished, we just Q3. Well, this has to be changed. First thing we do is we do GameManager, decrease player lives, and check if GameManager player lives is not equal to 0. If it's not, we respawn. Else, we PV3, and also I will leave a comment that end the game, right? How do you do? Oh, end the game. Okay. So that's it, I believe. Going back to my GameManager will decrease the player lives. Okay, let's try this for 5 seconds. I am invincible. And then I crash into attack and I should respawn. And I do, and I start as invincible. Perfect. So, and the lives should be decreased. Yeah. So all of this is working, which is very good. And we have our invincibility system and the respawn system done. Thank you very much. And we will go to the next section where we will handle the level transition and creating the levels. See you there. Goodbye. Hello and welcome back. So in this section we will handle spawning the upgrade or pickup when we kill given tank. So what's the logic behind this? When we are fighting against tanks, some of those tanks are flashing red. This indicates that given tank will drop a pickup or an upgrade whenever we will destroy this. So after destroying said tank on our grid, in a random place, there will be a box that you can drive through to get one of few possible pickups and upgrades. And there's a few of those. We will implement just, I don't know, 3 or 4, and I will leave the rest for you to implement if you want, because that's rather repetitive. So let's see. First thing, in our enemy spawner, we have to decide whether given tank should actually flash the color. We need to calculate some stuff. Going here to the tab, I can introduce a variable. And since we have stuff like enemy spawn index, total enemies per level, right? And we'll actually change this a little bit, because total enemies per level, we will make it dynamic based on the enemy array. So total enemies per level should actually be enemy array size. And given that, we can then say that the chance to spawn flashing tank can be calculated as chance to spawn flashing tank is a float of flashing. Let's see, we need to introduce the flashing tanks per level. We don't need that anymore, but I can introduce how many tanks should flash per given level. And I'm gonna say 3. So flashing tank per level divided by enemy array size. This is our chance to spawn a tank, and it seems I remove something. Oh, the enemies remaining is equal to total enemies per level. So this. So we have our chance to spawn the flashing tank. Then I can introduce also enemies destroyed variable. We'll use that a little bit later, but it is good that we can introduce this here already. Let's clear that. Okay, and with that, when we're spawning our enemy, we can decide whether it should flash. So let's see. Should tank flash, and the fact that it is flashing also means that it will contain an upgrade. Is less than chance to spawn flashing tank. And then we can just say enemy should tank flash is equal to should tank flash. Of course, we need to introduce that variable in our enemy class, so let's do this. This is enemy script, and we need to actually write it. So by default, should tank flash is equal to false, right? But then on ready, if should tank flash, we need to start flashing. And here in that function, we need to trigger that flashing effect, right? So that notion of slowly switching a color. And there are many ways to do this. What we could do is just use the animation. So we could do that by creating a twin and using a twin timer to move the color from white to red, right? But actually what I will show you is that manipulating materials is something sometimes better by using shaders. And don't worry if you don't know shaders, there's a lots of material about shaders in Godot. I'm not gonna be focusing specifically on it. I will just show you briefly how to introduce that flashing. So let's write that function. Start flashing, right? And what we need to do is, let's pass for now. We need to introduce new material in our animated sprite, since that node is responsible for actually displaying the graphics of our tank. So I can go to material here in my animated sprite 2D, and here I can select new shader material. I can click on it and I can create new shader here. So if you don't know what shader is just a very small program running on your GPU that takes one pixel and yeah, it takes one pixel and it outputs that pixel after being transformed. So we can take white pixel and display, I don't know, green pixel, right? We're just transforming pixel from pixel. So the difference between like writing a normal program and writing a shader is that you need to know that you're basically most of the time working on a singular pixel and transforming it from one color to another, or changing the intensity of a color, or changing the position of a pixel, right? So maybe a pixel that should be displayed right here would be transformed and displayed somewhere in some other place on the screen. Okay, so if we create a new shader here, and we can leave everything as a default, let's just place it in resources, and let's create shaders. And if we click on it, now what we have here is a editor for the shader language, and this is GD shader language, as you can see, which is slightly modified and adjusted shader. Okay, so shader language. So first, I would like to export some variables, and by default we do it in Godot with the export decorator, right? Here we say uniform, and in shader language every single variable has to have a defined type. So I would like to export a float and call this flash speed. I'll give it 2. Then I would like to export a vector of 4 variables. I will call this flash color, and I will say that this is actually source color, and I will initiate it to be, I believe, red. So 1 0 0 0 0 0, and the alpha is 1. Then and we need, I believe, a colon to end the line. Then I would like to export flashing intensity. So this is float. Okay. And we don't need a vertex, we don't need fragment. So what we need to do first is to get the texture color of given pixel, and we can use this because we have what is called a texture function. So I would say texture color is equal to texture, and we need to pass a texture, and then we need to pass UV, which are like the texture coordinates. Then based on the time, we need to find the color for a given moment in time that we'd like to display. And what we'll use here is going to be a sinus function. So if this is the axis representing time, and this one will represent the color, what I would like to do is get something like this, right? So this is going to be our red or flash color, and this is going to be our default texture color. So since I would like it to flash, right, and change the color smoothly, I will use sinus function in the time domain to get that color. Okay, so we will start basically probably from texture color, ramp it up to red, and gradually go down. And that's why you need to learn trigonometry, kids. Okay, so float, and that's going to be a flash value, is going to be sinus function. We use time constant here, which represent like the, well, the time, right, times flash speed plus 10. Okay, so let me explain this a little bit. What we're doing here, right? Flash speed plus 10 times expected time times flash. Oh, I did miss the column here, of course. Okay, so what we're doing here, we are multiplying this by the flash speed, right? So whenever we take a sinus function and we multiply it by something, it's gonna, let me zoom out, it's gonna take that function and it will get stretched. So the time of reaching the maximum of a function, it's gonna get longer, and also falling down to previous value, it's also gonna take longer. Then the sinus function basically goes from -1 to 1, right? So if we add 1 to it, what's going to happen? Well, its domain on the color axis is going to, because by default it goes from -1 to 1, it will move from 0 to 2, right? By default it's from -1 to 1, we're adding 1, so the domain is from 0 to 2. And then we multiply the output value times a half, which is going to bring it down to grow from 0 to 1, right? So now we are in this situation where by default we get the default texture color and then full flash color, and it goes back down. So basically what we did is we changed the domain of the function from -1 to 1 to 0 to 1, but we're also stretching it in the time by multiplying the input argument to that function. So this modifies the y-axis, so the color, and this as an input argument to a sinus, that modifies the size of the wave or the length of the wave in our sinus function. So this is our flash color, and then we need to calculate the final color. Sorry, vector 4 final color based on the flash value. So this is a mix of texture color, flash color, and a flash value. And then we need to preserve the alpha to make sure that it is always full alpha. And then we just say that the output color, this output of our shader, is final color, and add the columns here and here, and we have our flashing shader and its texture color. Okay, and then as you can see, it was parsed properly. So now we have shader parameters that we can access, right? So by default, I will say that flash speed is 0 and flash intensity is 0. Also, we can actually see it working. If I drag this down, let's set this to 2 and set this to 0.5. And you can see how it is looking, right? I can increase the speed and decrease the intensity. So this is how it looks like. So if I disable both of these, right, it's not gonna be flashing at all. So what I can do is actually trigger those parameters from the code. So going back to our start flashing function, I can say animated sprite material as shader material, set shader parameter flash intensity to half, and animated sprite material as shader material, set shader parameter flash speed and set it to 4. Okay, and I can probably get rid of that. So I am able to influence the shader parameters via code, which is really cool. And let's see where that works. So I would expect it to... Okay, I can see that it is triggered by default. And only two are flashing. All are flashing now. This is because to preserve the resources, all of the materials are being shared. So I'm gonna turn local to scene. So now every enemy has its own copy. And let's see. It starts as a red by default, and I don't want this. So let me check real quick what can be wrong here. We have a texture color. We have the source color. We have flash value, flash color, flash value, final color A, texture color, color, final color. Okay, so it's an easy fix. Let's just simply put those values as 0. Or we could just disable the material. So this is 0, this is 0. And let's see how that works now. It's still red by default. This is the flash intensity is declared by never used. Oh yes, of course, that's the issue. So the flash value has to multiply times flash intensity, right? Because we never used it. Okay, now it should be all right. This is, remember, this is random, so we might have to destroy some tags to get the one that should be flashing. We should be getting one already. So let's see. And let's reset those. No, let's leave those off. Flash intensity, maybe I made a typo, and flash speed. Flash yeah, there was a typo, of course. Okay, try this now. Okay, now they're all flashing. So this should be local to scene. I know what's the problem. Going to our animated sprite, we don't need local to scene, but what we need to do is make unique recursive. So let's click both of those, and now each node will get its own, not shader, but material. So let's wait for one to spawn. And they're still all flashing. Let's try with that. Yeah, now we need to make local to scene, and only one should be flashing. Perfect. So that's what we wanted. Also, as you can see, we can still spam our shooting, which is not good. So let's fix that real quick. Going to a player shooting system. What we need here is, let's see, can shoot is set to false and can shoot. And now I shouldn't be able to, yeah, spam the bullets. Perfect. So that's it. That's how we can use shaders to create flashing material. Thank you, and I will see you in the next one. In this section, we will handle the upgrades. So what we have now are the flashing tags that should spawn the upgrades for player to pick up on our tilemap. Let's start by defining upgrade definition. These are pickups or upgrades. I'm gonna just say upgrades. So in our scripts, let's create new script, and I will call this upgrade definition, and it's gonna extend the resource. So let's create and open it up. This is going to be rather simple, because what we need here in upgrade definition is the type. So export enum, and that's gonna be helmet, freeze, grenade, and they're all gonna be of type 3. And also we need to export the texture for it to have some kind of visual representation. With that defined, I can go to resources and create new folder, call this upgrade definitions, and I'm gonna define few things here. Let's see, we'll define free, upgrades. So let's create resource, and let's call this one freeze. The other one, I can just duplicate this. That's gonna be grenade, and the last one is gonna be helmet. So these are all easy definitions to make. Let's quick load the script. First, this is freeze, so let's select the proper type, and then for the definition, I'm gonna go and create new atlas texture. I will load the atlas, and I will use this one, and then I can edit region, and the freeze should have the timer icon. So let's make sure to cut it out properly. Perfect. Then for grenade, I'm gonna do the same thing. Let's load this. And that's the grenade. Okay. And for the last one, let's quick load the script. And that's the helmet. I'll load the proper region, and that's the helmet. Okay, that looks good. Okay, so you have that. It will be really easy for you to set another upgrade like extra life, right? You would just follow the very same process. So next thing that I'm going to do is to actually define the upgrade scene, which is going to be very simple. So let's choose area. Let's add a sprite to D, and let's add a collision shape. And the shape of the collision shape, oh, let's also name this upgrade, save it in scenes. So the collision shape is going to be rather easy because it is going to be just 16 by 16. So we can adjust this. And we can add very simple script called upgrade. Let's do the class name. And it's gonna accept the upgrade. Can I bump it up? Upgrade definition of type upgrade definition. We will need the sprite, and all we do is on ready we assign the proper texture for the correct display, and that's it. Then we need to actually assign a layer for it. So in project settings, to the physics, I can create an upgrade layer and say that in collision it exists on layer 6 and it collides with tank, which is our player layer. Okay, so we have that. Now we need to go back to our enemy, and let's see, we have explode, and when we QE free, right, we'll emit a signal. tank destroyed should spawn upgrade which is of type boolean. So here, before we q3, we say tank destroyed emit should tank flash is an indicator that given tank should spawn an upgrade. Okay, and we will handle this in enemy spawner. So going back to enemy spawner, we spawn a tank here, we connect to it, and actually we can change the connection here to tank destroyed signal, our custom signal that will have information about the tank being destroyed. So here now I'm going to get information about should spawn upgrade of type boolean. Okay, let's see. If we should spawn upgrade, we'll delegate the spawning of this to GameManager. Spawn upgrade. Okay, what else can we do? We can say that enemies destroyed is equal to +1. Okay, and then if enemies destroyed is equal to enemy size, we can also say GameManager on level completed. So let's add those two functions to our GameManager. Let's see, should no, that's spawn upgrade. We'll pass it, and on level completed, and we'll also make it pass for now. Perfect. Let's focus on spawning the upgrade first. So I will also not do this directly in GameManager, even though I could, but I will delegate that information to another node that will only be responsible for that. So let's use game2d node2d node, and call this spawner upgrade spawner. Okay, upgrade spawner, and I will add a script to it. And let's start by adding class name upgrade spawner. Perfect. So what we will need here is an information about the possible places where the upgrade can spawn. So we can use marker2d nodes to figure out where we'd like our upgrades to spawn. So let's make it a child of upgrade spawner, and then let's just create a few of these and move it around. Okay, so we have like 1, 2, 3, 4, say 5, 6 potential places for this. Perfect. So we can go to our script, and then we need to get that going. So let's get the reference to upgrade scene, and we can preload that as an upgrade tscn. Let's get the reference to potential spawn points of our upgrade, and this is array of marker to be. Can I get all of these in one go? Yeah, I can. Perfect. And then we need the upgrade definitions. That's array of upgrade definitions. I can just say preload grenade tst rests. Then we need freeze definition, and then we need the last definition, which is helmet. Perfect. Since we would like to call to that node from the GameManager, we need to give the GameManager reference to it. That's really easy. I can just say GameManager upgrade spawner equal to self. And then in GameManager, I just need to define that reference. So the upgrade spawner, let's see, I can just say upgrade spawner is upgrade spawner, and when this node is ready, it will assign itself to GameManager so that we can call to it. Perfect. Then the next step is to spawn the upgrade, and we will get random spawn point, sorry. And random upgrade definition. We will instantiate it. So upgrade scene instantiate, and we will assign the upgrade definition, and we will say upgrade global position is equal to random spawn point global position. And then I can just say get free root at tiled upgrade. And in theory that should work. Let's check this. Let's try and get, oops. And I cannot shoot anymore. And that might be a bug with our shooting system. So by default it should be true. Okay, this one starts with an upgrade, so let's try and, oh, I can shoot only once. Let's see. Bullet destroyed. Let's see. Signal bullet destroyed. We're not emitting this. So let's do this right here. Yeah, now it's fixed. Okay, so that's one tank gone. Next one, I just the one with the upgrades. Okay, we have one, and nothing. So we are missing something. Let's see, enemy spawner, if should spawn upgrade, enemy destroyed, spawn upgrade. Oh, we're not calling the upgrade spawner. So upgrade, upgrade spawner, spawn upgrade. Okay, now let's try and kill it. And we have an upgrade. Perfect. So in the next section, we will actually handle the interaction between the player and upgrade to trigger some effects. And I will see you there. Thank you. So in this section, we will handle the interaction between the upgrade and player. So to do that, we need to actually do a few things, because two of the upgrades that we have, grenade and freeze, should impact all of the enemies, and we need to have a way to access those. So in our I believe enemy spawner should be good a place, or we just in our enemy going to ready function. What I can do is just say add to group enemies, right? So now we should be able to have a node group, and all of the enemies that we spawn should actually be in that group. So with that, we can just go to player, and what we will do is create another node here, and that's gonna be empty node, and I will call this upgrade handler. Okay, and what we will do here is whenever we hit an upgrade, so if area is upgrade, we will create a script here, call it upgrade handler, put it in scripts, handler, and I will create a function here called handle upgrade that will get basically upgrade type string. For now we will pass. So here I can just say where is it? Oh, that's the enemy. I need this to be in player, sorry. Let's get a reference to it, and I need to call, let's say, upgrade handler, handle upgrade, and I will say area as upgrade, and we'll pass this other upgrade definition type, and I will of course free the area. Perfect, and then let's handle the upgrade. So we have 3 upgrades here, right? I can say if upgrade type is helmet, this is the easiest one. Also get parent invincibility system start invincibility. This is the easiest one. Else, if we have upgrade type of type grenade, I will get the reference to all of the enemies by calling get 3 get nodes in group enemies as array of enemy, and for enemy in enemies I will say enemy explode. Else, if upgrade type is equal to freeze, I will do the very same thing, but I will just call enemy freeze function. Of course, that function does not exist yet on enemy, so let's go to our enemy. And let's add that function at the bottom. So what should happen when we freeze an enemy? Basically, it's rather easy. What we need to do is set the speed to 0. We need get the node that represents a shooting system. So enemy, where is it? Enemy shooting system and shoot timer. So basically I can probably just drag and drop it. So and I can say stop, and then I will await some time, let's say 4 seconds. Let me get some space here. Create timer 4 and await the timeout, so I can create inline await for given time. And I will grab the very same thing and say, then get back to shooting and set the speed to tank type speed. Okay, let's try and test this. As you can see, I'm not that good at the game. And we have a flashing tank. It gets destroyed, and that should wipe out everything. And it doesn't because of one thing that we forgot. And this is to enable our player to be able to collide with upgrade. Try this again. And I'm waiting still for one of the tanks to be flashing. Maybe we need to adjust. Yeah, okay. So what we have here is the grenade, and we destroyed every single enemy, right? Okay, cool. I believe that's enough. I would just assume that the others are working, and I hope so. But given the time, I'm not gonna be testing those. So that's how we can handle the upgrades. And of course, if you would have like extra life update, what you could do is just go to GameManager, and since this is globally available, this is singleton, you can just bump up player lives. or call something like upgrade player lives, add to player lives, and then update player lives in UI. So thank you for that. In the next section, what we'll do, and I believe this is going to be the last section, we'll create that opening game effect where, well, you'll see. See you in the next section. Bye. Okay, so let's get going on that transition to start the level. And if you don't know what I'm talking about, just when you start the game, it has like those curtains popping off and stating level 1, and then after that the level loads. So what we need here is to actually higher level node that will manage the scenes that we'd like to present. So I'm gonna grab that main node that we have. Let's see. Let's find it. And I will rename this to level 1. And also here I will rename this to level 1. Okay, and get rid of it. So we have our level 1 node, and it still works as expected. Okay, let's maybe see what we can get here. Freezing. Is it working? Yes, perfect. So another upgrade tested. And then I will create a new node. And that's gonna be our main game node. So I will just create other node, empty, and I will call this just game. Okay, and let's save it, and let's give it a script. Okay, and then we'll also need level transition node. So let's create that node, and that's gonna be, we can use node 2D probably for that, but it doesn't really matter. So node 2D, call this level transition. Let's save this. Let's give it a script. And what we need to start with is actually defining what we'd like to have here. So I will start by adding canvas layer. And then let's create those curtains that go down. So I need two color rectangles. I'll call this one top curtain, duplicate it, and call this, of course, bottom curtain. Select both of them to assign the color. You can go with night grayish, and we need to position them correctly. So we need to make sure that they span across. Okay, and then for the sizes, we'll basically calculate them. So do we need anything else for those? We could like define them to have them visually set up. So going to layout for the top curtain, I can go to transform, and the size I can go 3 to 4 because that's the half of that. And then I need to put it to bottom, and then go to layout and transform, and also do 3 to 4. The problem with that one is that actually that one should be placed like above, right? And that should be 0, and -3 to 4. So this is let's see, 0. This is where they're placed on the start, then they come down and display the label -3 to 4. Okay, but we'll handle all of it with the code. And then we need a label. So let's find the label, paste here. Make sure that the position of it is center. I can just present text like level 1, and just to make it a little bit better, I will change the font, close our font, and let's see, I can also increase the font size, or maybe not. I believe this is good. So nothing special there, just 2 color rects and label. And then we need to code the whole transition effect. So let's grab some space here and add a class name, level, transition. It will emit a signal informing us that the transition has finished with level number. I will define curtain color. By default, this is going to be 3F. This is going to be gray. Then we need the reference to top curtain, bottom curtain, and level label. We need information about the screen height because they differ, and it can be obtained from project settings, get setting, and that one is viewport height. Then we need the curtain height, which should always be a half of the screen height. Animation duration, and current level, and it starts as 1. Okay. Already, what should we do? We need to place the curtains in the respective positions. So top curtain position Y is minus curtain height, and bottom curtain position Y is equal to screen height. Level label text should be equal to level %d percent current level, and level label should not be visible, so high. So this is the setup that we want on the start. Then we need to start the transition. And let's create that function. We'll create twin. And we will twin property, and the property is top curtain position Y, and we twin it to 0 during animation duration. And in parallel, we twin property of bottom curtain position Y, curtain height, animation duration, and we need a callback here. The callback is show, label, and reverse. So after we put the curtains via the animation to proper position, we need to show the label and reverse the animation. So show label and reverse. Level label x is equal to, we already set the proper level, so I don't need to do that actually. Level label show, we'll wait for 1 second, so get free, create timer, 1 second, timeout. Then we hide it and we slide out. Standalone lambdas. Sorry, what is wrong here? Show label and the reverse. Standalone lambdas cannot be accessed. It's not standalone. Create timer, timeout, show label and the reverse function. Oh, the indentation. Okay. So the slide out, it's very much the same. So we create a tween, we tween the property of top curtain, position Y minus curtain height and animation duration. And in parallel, we tween property of bottom curtain, position Y, screen height, animation duration, and we call back to slide out. Finished, which is going to do one thing only. Transition finished, emit. Perfect. Okay, so if we run that scene, you can see how it works, which is great that you can run the scenes in isolation. So we need to use this in our game. Okay, so let's grab the reference to transition scene. So const var or just transition scene is equal to preload transition tscn. We need to have the current level instance. We need to have the transition instance, and we need to have current level number. Okay, and already what we will do is we will load level of current level number, which is going to be level 1. So this is going to be the most important part of our loading process. So load level, level number, which is int. If there is current level instance, we need to QE free. Sorry, we need to QE free it. QE free. And this is because when we transition from level 1 to level 2, for example, we need to free the previous level. if there's already a transition instance, we need to give it. And then we start our transition, and we do it by instantiating it. And I can say that transition instance, this is, well, I could instantiate it as a level transition. So now I can say transition scene, sorry, instantiate. Okay, and I can say that transition instance current level is current level number. I can just say add child transition instance, and then I can say transition instance transition finished connect on transition finished. So we just make it run, right? And then we need to actually display the level when the transition is finished. So on transition finished, we need to load the current level scene, and this is scenes and level %DTSTN, and we just pass current level number here, current level number, and we say current level instance is equal to current level scene instant, and we can say that this is packed scene. Maybe we don't need to pass it here, but rather here we can instantiate this, and yeah, we have that. And I can say add child current level instance, and if we have transition instance, just to be sure, well, basically we can queue free it, and that then we don't need that, but we can leave it as it is. So we have a game, and let's try and run it. Perfect, and we have our game loaded. So this is how we can actually make that transition. And in the last section, what we will do is we'll create a simple summary screen and somehow load another level. Okay, so this is going to be the last section for our Battle City game, in which we will display a simple summary screen after the level is finished. So we'll start by going to our enemy spawner, and what we need here is information about destroyed enemies. So let's create this enemies destroyed data. It will be based on the enemy array. So it's going to be a dictionary. Let's start with basic. Points for that is tank types, and I believe we should have the tank types. Yeah, we have it. Tank types, basic points, and amount. Oh, and it's the dictionary. We need two strings here. Amount is enemy array filter, and let's use inline function here. Enemy is equal to basic size, because the screen will get displayed only if we destroy all of the enemies, so we need know that we had to destroy every single enemy in the enemy array. And with that, we can go to fast. And I can just basically copy that and replace this with fast. Then we have the power. And amount, and this gets replaced by power, and armor. We can copy that and replace this with armor and armor. Perfect. So when we finish the level, so on level completed, I will say enemies destroyed data goes to GameManager, right? And in a GameManager, I can just say that it accepts enemy destroyed data. So enemies destroyed data, and we need to display the summary screen, right? So we need to create this. Let's go to let's create a new node here, and that's going to be a canvas layer. And let's call this summary screen. Save it and add a script. And let's actually give it class name summary screen, and we need to build that UI, which is going to be rather simple. So we need a color rect and make it span across and make it black. Perfect. And then we need margin container. And also make it span across, and in theme override with 32 or any other value that you'd like. And then we need a VBox container, and we will start by saying adding a stage label here. So label, and let's just do level 1, center it, and let's change the font, and let's change the size to 24, and then we will create 8 boxes. So 8 box container. So let's see what we need here. We need points label, count label, and texture rect. So let's see, label, another label, and texture rect. Okay, and this is going to be points label. This one is going to be count label, and this we can leave as a texture rect. And let's try and see what we need here. I will add a separation here of 42 for HBox container, and this is like singular entry, and this should be here, and this should be above. And I will add separation of 42 here. Perfect. So here, for example, I would like to say so many points. And again, for both of these, we will do theme overrides, fonts. I could use a theme, but you know, these are minor changes. It is faster this way. And I will bump it to 32. Change the color of that to be red. This can say white, and I will, for example, say 15. And here I would like to include the texture representing destroyed tank. So let's go to new Atlas texture. Let's load our Battle City 5. Let's edit region. And grab that. It should be basically 16 by 16. So maybe like this, and this. Okay, as you can see, it's rather small. So what we need to do is set custom minimum size. Let's see, layout, let's say it should be 64. Expand mode, fit width, proportional, and scale. And now we have our first entry, and we can duplicate this, and I will call this basic. This one I will call fast, and here I will create new Atlas texture. Do the same thing to load this, edit region. It should be also 16 by 16. So this and this can work. Okay, we have that. Duplicate this. This should be power. Repeat the process. Let's do 16 by 15 by 16. Okay, and the last one is armor, and we need to create new Atlas texture. And let's adjust that. 15, 16, 16 by 16. Perfect. So we got these. And then let's start scripting. So this is going to be a little bit repetitive, and we could make it simpler with just making this into a separate node, but this is simple enough, so I guess it's okay. We'll use the enemy skill data to populate all of these 8-box containers. So I'm just grabbing references to those. And armor, okay. And here I can say basic data. It's enemy skill data and basic is the key, and then I will just say basic get node points label text is equal to basic data points times basic data amount, and then let me move this out of the way. Basic get node count label this is SCR basic data amount. Oops. And this needs to be closed. Okay, and then we repeat this for every single entry, right? So I could make it into a function, but in this case I'm just too lazy. And we do fast and fast, and we replace all of these, and then we do power we grab that, power data, and we do the same for armor. Armor data. Okay, so how to actually use it? We go to our GameManager and we need to fill out this function. So GameManager, we need the reference to summary screen scene, and we load it as summary screen, and this is fact scene, and then we say summary screen is summary screen scene instantiate, and that is summary screen enemy skill data is equal to enemies destroyed data. We queue free the UI, and we say get free root at child summary screen. So now after the level is complete, we should see the summary screen. The problem is how to test it and how to trigger it. Well, we can go to enemy spawner and adjust our enemy array. Let's comment that for now and say enemy array, and let's just try and spawn 2. So I will spawn basic, fast, and basic. And because of how our whole enemy spawner is set up, that should present a summary screen. Let's see. Picture of type nil. Basic. Oh, I should probably run the game. Invalid access to property or key basic on base object of type nil. So the tag types are null at that point. So what we can do, because this has to be preloaded, is to basically move that here and fix the indentation, and now it should work. Okay, so let's try and destroy our enemies. 1, 2, and 3. And this presents the summary screen. So this is working. Cool. So now to loading the next screen, what we could do is go to our GameManager, and we can say, well, let's see, we could just go to summary screen, and here what we could do is listen for any key input from our player, and I could just say input, see if event is input event key and event is pressed is pressed, and then I can just say get node as game, and we'll create a function here called load next level. We'll QE3. Get node, and we need to provide, and this should be root game, and then game is not in a scope because probably we did not define the class here. Okay, load next level, and we need to create that function. So we have load level, and then load next level is just current level number plus equals 1, and load level, and that's gonna be current level number. Okay, perfect. So we have that. Then it's just a matter of creating another level. So what we could do is create scene, new scene, oops, sorry, not that. Scene, new scene, other node, empty. I'll call this level 2, save it, and here I'll just display label at the top stating level 2. And what you could do to actually set the second level is to copy most of the nodes from here, right? The tilemap layer would be, of course, different. Maybe the spawn points would be different, but you would copy most of the nodes and trigger the second level. So let's see how that works. I am going to game and running that scene. So we load level 1, we destroy the enemies 2 and 3. This is the summary screen being displayed. I press space and level 2 is being loaded. And there are some leftovers before because we probably should clear all the spawn upgrades. But that's it. That's how you could transition through levels and space summary screen. And this finishes our Battle City tutorial. I will be pausing stuff for a while. I have lots of responsibilities, but I will come back in some time with something a little bit different. So see you there. Goodbye.